3D printed cream cheese, Uncle Jessy is having some problems with his XL, and a interesting Bambu failure where the filament got stuck. And I mean really stuck. All this and more, PrintFix Friday, episode 105. I got the number right this week. Let's get into it. Hey guys, welcome back to the channel, and if you're having some issues with your 3D printers, we're here to help you. But hey, first, make sure to leave a like and get subscribed if you aren't already. If you do want to get some help, you could reach out to us on all the social media platforms, slide into those DMs. Doesn't cost a dime at all. You can even email us, youtube@3dmusketeers.com, and I will do my best to help you get back to printing purposefully. It's nice to get those old rickety machines back up and running with only a couple of extra screws. It is for weight savings and aerodynamics. I promise. We have some interesting print fixes for you today, and I guess we'll call it a final update to my Bambu Lab X1 Carbon series. But there is a way more interesting Bambu Lab failure that I didn't see coming. It is not mine, but you'll have to wait to hear that one. Let's jump right into 3D printing cream cheese, because you're gonna have nightmares now. I'm sorry. 3D prints looking like cream cheese. That's a way to put it, I guess. Let's see what they got. Hello everyone, I've posted once before and got a lot of good advice, but my prints are coming out wavy or fuzzy and just off in a way that's hard to narrow down. I printed a full-size Benchy this time and have been tweaking my settings. I also tightened my belts and got a new build plate. I did a pull to make sure my nozzle isn't clogged. I was advised in my last post to upload my Cura settings, so I'm attaching them as well. Any advice is greatly appreciated, and thank you everyone. Can't fault them for being really kind. Gotta love it. Good job there. There's a lot of things wrong with this Benchy, and unfortunately, she's not extruding properly. So it could be, there are a lot of potential problems going on here, but the one that's leading me to that it's not extruding properly is this here, because we see a lot of lines and they're diagonal. This is normally caused by filament that's not coming out of the hot end. If that's the case, I am guessing that we either have a clogged nozzle, our extruder isn't working correctly for some reason, or we have our extrusion rate is a little bit low. But this thing is not properly extruding. We can see this. Let's see what we got. Is this an old version of Cura? God, it's been a long time since I used Cura. So we can see the build plate temp is at 65 and then maybe goes up to 80. No support, anything like that. Wall thickness of 0.8, infill density of 35%. Infill layer thickness is just calculated. Printing temperature is 225 with the flow at 80%. So you don't want your flow that low. You might want to get some flow max. That'll help, or just turn your flow up to 100. When you have flow below 100%, that means the stepper motor is actually moving less material. And in your case, you have a lack of material here, so we want to make sure we put that up. If you put it up to 100 and it doesn't solve your problems, we've got other things we need to look at. Primarily, let's take a look at that extruder, and let's take a look at the hot end. Just because you did a cold pull does not actually mean that you cleared a clog. If there does happen to be a clog, you will want to do a cold pull. Cold pulls are relatively simple, so let's go through them real quick. You want to heat up filament and extrude it through the nozzle. Then let everything cool down to about 100 degrees centigrade or so. Release pressure on the extruder and then just rip it out of the hot end, and you do that until it comes up clean. If this is a printer that you've had for a while, your Bowden tube might actually have a bunch of garbage in it, and that could viably be creating excess pressure inside of that PTFE tube, creating an issue where you're not getting the extrusion that you should be getting. Remember, on printers without all metal hot ends, the actual PTFE liner, which is normally also your Bowden tube, is a replaced part. It is a wear item, but we don't know much beyond that. We don't know the printer. Maybe we'll get lucky. Okay, we can see it's an Ender 3 with a 0.2 nozzle. That's gonna adjust things. So what layer height? You're doing 0.16 layer height. That is at the absolute maximum you can run with a 0.2. But if your workspace is not incredibly clean, minimal dust, you're going to get clogs from freaking dust. Do you have long hair like I do? Yeah, you're gonna clog a 0.2. In fact, just looking at a 0.2 the wrong way will cause it to clog up. You also want to make sure that you're setting your nozzle diameter appropriately in the slicer. If that's not done, we might have some problems here. So here's something to point out as well. They changed the nozzle because the one came with it was messed up since they got the printer used. That's a big red flag. If the printer is used, you absolutely want to just toss out the piece of Bowden tube that is in it and outright replace it. We don't know the quality of it. We don't know how long it's been printed. And quite frankly, we don't know what kind of gremlins come with a used printer. We have a video planned on this because I got a printer from one of our Patreon members and local fans that they just did not want anymore and could not get it working. Maybe we'll do some live stream content on it where we try to get it up and running because I have no idea what's wrong with it. And neither do they. But to replace a 0.4mm nozzle with one that is 0.2 for the sole purpose that it will provide more detail is a bit of a misnomer. While yes, a 0.2mm nozzle will provide you with more detail, it will print much slower. Remember, standard layer heights on a 3D printer are 0.2mm. If you're using a 0.2mm nozzle, you can't go anywhere near that high. And in fact, the equivalent of a 0.2mm layer with a 0.4mm nozzle is a 0.1mm layer with a 0.2mm nozzle. Your prints will go up exponentially in time. I would really just focus on sticking with a 0.4 for right now, and until you're really ready, it's not time. Because we can see that there are some things that have been held over from the 0.4mm nozzle profile that haven't been adjusted here. Things like wall thickness. 0.8mm wall thickness with a 0.2mm nozzle is, I hope, around 3 perimeters. If it's more than 3, you do want to make sure that you're running at least a 0.22 or a 0.23mm line width. There's a whole video on it that Stefan of CNC Kitchen did where he shows that, yeah, adding a little bit of extra width to your extrusion line actually helps out considerably when it comes to strength. But a 0.2mm nozzle is just not good, especially if you're relatively new to this and the printer is used. I would recommend transitioning back to a 0.4mm nozzle when you can. Look at replacing that Bowden tube, assuming it is not an all-metal hot end, and go ahead and check that extruder. Ender 3s have plastic extruders, which are a little bit notorious for having breaks. They can actually, over time, get stress fractures and snap. It's why we recommend that one of the upgrades that you do to an Ender printer is to put a metal extruder on the machine. You can get ones that are just direct factory drop-ins that require no extra tuning and they work great. Or you can look at ones that are dual drive where there's a gear between the two hobbed gears that actually drive the filament. That way it is being driven on both sides rather than one side with an idler hitting it. It makes for better extrusion, but be aware, some of those do require you to recalibrate your steps per millimeter. Future video. Get subscribed. The other thing, get rid of the white filament. I don't know what it is with white filament, but especially white filament with a lot of white colorant in it, which is normally titanium dioxide, if I'm correct. So many problems with it, especially when you're dealing with small nozzles. Those particles of titanium dioxide can and will not only damage nozzles, but they will actually start to clog them if you're not using good quality filament. And no offense, Creality is not known for their filament quality. Inconsistent Z banding along the X-axis. Hey there, I have an Ender 2 Pro with around 2 months of use. This little beast has been printing spectacularly. This little beast has been printing well, until a few days ago when I started to have some severe Z-banding along the X-axis. If it's Z-banding, it wouldn't be along the X-axis, but I digress. Here are some images for comparison. The third photo is before, the first two is with the Z-banding artifact. Any help would be greatly appreciated. So yeah, we definitely have some sort of like ringing or some looseness somewhere in the system. Yeah. Are you sure that's the X? Because that looks like that's along the Y. I'm going to have to trust that they know X, Y, and Z on the machine. But in a case like this, especially on an Ender 2 Pro, Ender 2s are cantilever printers. They only have a Z on one side. If that is true for yours and you haven't done any mods to give it a second Z, you want to make sure that that Z axis is tight. If it loosens up and can get a little wobbly, this could be caused by that. But things like your V-wheels coming loose and wiggling a little bit, belts coming loose and wiggling a little bit, heck, even your pulley on the stepper motor coming loose and wiggling a little bit would cause this. I think it's time we revisit the terms video where we talk all about the certain terms, what they mean, and what they look like. The hard thing is actually to do what they look like, because it means I have to force failures on printers, which is not as easy as you would think, because things like Z-banding, it's really difficult to do if you have a printer that's reasonably well tuned. But this is not Z-banding. Z-banding would be a consistent adjustment to the way that layers are printed, and it would normally tend to have a wavy pattern. That pattern would normally line up in some form with the actual lead screws for the Z-axis itself. This is not Z-banding, in my opinion. I'd love to know what you guys think of this one. I don't think it's Z-banding. Stuff like this tells me something is loose, and most likely it's gonna be the hot end on the X-axis. She might just be a little bit wiggly. And while 2 months is not a ton of time, it's also not an unreasonable amount of time for V-wheels to start to come loose, especially if you've been printing a lot. See, it's not about time of ownership, it's about hours of machine use. The more hours you have of machine use, the more likely those V-wheels are to get worn. Now, we've covered adjusting V-wheels in the past. We'll card to that video so you guys can take a look. And now that we're getting some better cameras, maybe it is time for us to revisit that with just some better filming work. Or maybe that's how we launched the Making Awesome Academy. Yeah, details on that coming soon, but it's going to be all about product development and an entire section dedicated to those that are really struggling with getting their printers running, with hardcore in-depth videos about it, with very little cuts, lots of detailed photos and video that it doesn't really make sense for YouTube because the format is very long, and YouTube doesn't like it when we make long videos. Hey, that's content creation for you. Can anyone tell me why this keeps happening? I'm trying to print this Ghost Dragon model, as this happened twice now. It gets to around 80%, then I start to hear my extruder making noise and my hot end clogs. I recently dried my filament as well, and on shorter prints, it has been working fine. It's an Anycubic i3 Mega X, and they've dried the silk PLA filament prior to printing for 6 hours at 50°C. They are honestly extremely confused as to why the whole print goes well, then the last 20% clogs. Welcome to Silk Filament. I will go ahead and be your guide for the day. This is not because the filament is wet, because as we know, it's not wet filament. Often, when people say it's wet filament, it is an absolute ridiculous claim. This filament's not wet, and it probably was never wet. This is one of the huge problems with silk filament, and actually why we tell people not to print dragons or anything that has a lot of detail with silk filament. Silk filament has a coating on it. Some think that it's PETG, some think it's polycarbonate. I don't have a spectrum analyzer to tell you, but hey, if you do have access to one, let me know. I'd love to know. But the problem with silk filament is it work hardens like a son of a bitch. It is so bad. And if you're doing lots of very small movements with lots of retraction, this is a Bowden printer after all, so it needs a lot of retraction, that material is not only going to shrink, but it is also going to get harder. And the harder that it gets, the more difficult it is to extrude, thereby creating the clogs that you have. This is not your fault. It's the filament's fault. And unfortunately, this is what happens with silk filament. There are some ways around this, but it involves just superheating the filament. You need to print it at really, really hot temperatures, like 230, 240 degrees centigrade for silk. And yeah, that's probably going to cause it to ooze. It's probably going to cause it to string. But if you don't want to create this issue, you must superheat the filament so it doesn't have this problem anymore. I have battled this before. It's actually why you don't see us print a lot with silk filament for time lapses on our Prusa rig that we have right behind me, because that retraction that it needs to do and then the wait for the camera to take the photo is so long that it tends to actually damage the filament as it's occurring. And while, yeah, smooth time lapses are really cool and octolapse is great, the silk filament is just best to be done on prints where you don't have a bunch of small movements. I don't have a great solution for this. I know of a lot of people that struggle with this same problem, and we all just say, screw it, it's the filament, it's not me. So if nothing else, it's not you. It's probably your filament. And that's not because it's wet, that's not because it's bad, it's just because it's silk filament, and that is the way of the world. Next up, Uncle Jessy. Been on the channel a few times. In fact, we interviewed him a long time ago. Maybe it's time we revisit that interview. Clayton, let's get together. Let's talk about some of your challenges that you're having with some printers. I'd love to be able to help, but he recently got in a Prusa XL, and suffice to say, things haven't been going all that great. One of his first prints, the nozzle just dug right into the print, and it's not like it just dragged across the print a little bit. No. That nozzle just went for the field and just absolutely decimated this print. I don't know why. This to me screams that something else is wrong. The Prusa XL, for those who don't know, is a Core XY printer, which means the bed goes up and down. And unless there was a bad line of code, let's say the bed broke for some reason and the motor stopped, the bed would fall. It wouldn't go up. So for the nozzle to slam into the part like we see here, the bed actually has to move up, which takes a command to do it. I am guessing that something happened here inside of the G-code. And I feel for you, Uncle Jessy, because damn, man, it's like so close. It appears to be a Batman helmet, maybe? I'm honestly not that good with fandoms. I'm sorry. But it just needs a little top hat, obviously. You just put a little top hat on it, whole problem goes away, you're good. But no, that's not going to fix any of this. What might is taking a look at that G-code. This is very close to the end. Like he said, it's right there. I mean, we're maybe 10, 20 minutes max from the end of that build. And what you can do is you can open up that G-code file inside of a text editor, like Notepad++. You then search for Z, because Z will show you the Z commands, and then just hit down. Watch those Z commands to see if at any point in time that command goes up by quite a bit. It looks like we dug the entire nozzle in, and while I don't have a Mark IV or an XL, so I don't have the brand new neck extruder here to show you guys, that looks at least an entire nozzle depth of distance here. That's a fair bit. If this was one of the multi-tool head XLs, I could say, okay, maybe during a tool change, maybe the hot end itself wasn't properly attached. That could be the problem. I'm not sure, but there is something to note. We've seen this in our own Discord. Yusuf, I'm gonna call you out for this one. He was battling first layer on his Mark IV for like 3 days, and then he finally realized his hot end wasn't all the way tight. It actually wasn't seated all the way and then properly tightened down. While the neck extruder is pretty cool, and I still believe it needs a clear front, I think maybe the hot end got loose and fell. It's a complete and utter guess. That would absolutely track here of how deep that melt actually goes into the part itself. But the bed got messed up too. He said, no idea how this happened, but the bed looks out of alignment now. This was perfectly level previously. The right side is now higher than the left. Totally agree. And unless there is some sort of fun parallax problem with your camera, your bed is out of whack. And Pooch, a XL beta tester, chimed in here and said, printer fall down, go boom. It happens, but it's frustrating. Bed alignment is no biggie though. Recalibrate Z and you're back in business. That's a nice thing about printers that have independent drivers, or minimally the ability to know that just let it run into itself for a little bit. As dumb as it sounds, just letting the printer run the Z into itself so it self-calibrates is often one of the best ways to do it. It's so good. The Mark III does it. The Mark IV might do it. The Sovels do it. While Sovel doesn't put enough current into their stepper motors for that kind of thing, it is really effective in most use cases, and the XL appears to do it. Last but not least, we have one of the weirdest Bambu fails that I've seen. This comes from one of our Discord members, Chris, who has a Bambu Lab X1 carbon and has a really unique problem. The filament and Bowden tube is stuck right in there. In fact, you can see how it's stuck. We work together to get everything apart, and because it is so tight, he actually can't pull on the Bowden tube connectors to get the Bowden tube itself to release. He is using an AMS. You would have to rip it completely through the AMS, which he tried and could not do. And because Bowden tube is under compression, you can't stretch it if it's getting stuck. We worked on this one and it took a little bit. He got to this point on his own. I had him remove these 2 small screws, which allow the filament runout sensor to come out of the machine. He can set the rest of the extruder to the side. From there, we ended up saying, screw it, we have to cut the Bowden tube. You can see he cut the Bowden tube right at the top of the coupler, and we can see our problem. His Bambu Lab X1 carbon failed to cut the filament. Why? We still don't know, because it worked one time, then it failed the second time, and then it worked a few other times. I haven't talked to him since. This is kind of an odd one, and this is obviously why Bambu does this kind of thing. The cut and then the Bambu poop that we know is actually a really ingenious way to handle this problem. Because if you cut your filament with a smooth end, removing it from your filament path is actually, theoretically, really, really simple. But if you don't cut the filament, it can, well, make this little hook that you see and get stuck on something like your filament runout sensor. And as dumb as that sounds, boy howdy, that would just really get your jimmies in a twist. And yeah, it did for Chris. We can see that he took the Bowden coupler out and, well, after vigorous application and careful cutting with a hobby knife, he was able to extract all the pieces of the PTFE, only really losing about 3 or 4 millimeters. Now, thankfully, Bambu does not use any custom Bowden tube, and in fact, they use the regular 2mm ID, 4mm OD PTFE tube that you can get on Amazon, ubiquitously cheap, and in fact, we will link to a roll of it in the description down below, because you buy a 30-foot roll and you pretty much never need to buy more. I think my last time I bought it was 5 or 6 years ago, and it's finally time for me to buy more. But when you're only cutting off 3 or 4 millimeters, it's not that big of a deal. And we can see he got it put back together and assembled. With talking to Bambu Lab, they recommended that he actually print and install this PTFE guide. The other thing to note is that this is an old X1 carbon. It looks like it's at least as old as my original X1 carbon because it has the older tool head board that instead of a ribbon cable actually uses wires. Now, I like the wires better than the ribbon cable. It's a lot less fragile, in my opinion, but hey, Chris has had a decent experience so far. I, however, heavily appreciate his sentiment here. I'm gonna read it verbatim. I may have done a thing. Running a test print now, leaving the AMS out of the loop. Fun fact, this is the first time I have printed on the X1 carbon without the AMS. Fingers crossed. But it passed the self-test and it loaded the filament. Good thing too, because I have multicolor prints that need to happen. Reuse the existing PTFE, which is a couple millimeters shorter because I cut it flush. Got one of those filament straighteners installed. Bambu actually suggests something like this because it is easier than saying, oops, we never realized making a hard bend with PTFE as it enters the hot end might cause a problem. But I will say the hot end is quite serviceable. I will agree with him there. It is a really easy hot end to work on. And I would know. I've done it quite a few times. Number of spare screws left over afterwards, 0. Number of unfilled screw holes missing their friend, 0. What I wanted, Bambu to tell me how to fix it. What I needed, Grant to tell me to go big and send it. So, thank you, Grant. He still doesn't have a response from Bambu about this, by the way. They replied back basically saying, hey, have you tried releasing the connector? Yeah, we did that. I know that Bambu support is being overrun by people that are having kind of newbie issues with their machines, but hey, that's part of it. And if you are having issues with your Bambu Lab X1 carbon, I want to help you. I've had a lot of issues with mine, objectively, and that means I think I'm pretty well versed in how to fix them, to be honest with you. Try me. See what happens. But on that note, I do have to say that I have made a decision. We are sending back my now second Bambu Lab X1 carbon. I thought on it for about a day after posting the Friday video last week, where we talked all about the special treatment that I was getting. While their customer support manager states up and down the road that's not the case, I am talking to the customer support manager when the individual that I was working with previously said that they could no longer help me, and then they realized that I was on their list of key opinion leaders. While I recognize that most companies do this, and Bambu has every right to do this, it is not my preference to get this kind of treatment. I've decided that just really because of that, and really, as lawyers would say, the preponderance of the evidence, it's just not right for me right now. I really want to like this company, but I've had so many tough experiences, and a couple of really good ones that it just really rubs me the wrong way, and it's time to sit back and see what happens. Bambu's got a lot of interesting announcements coming up in less than a week. Maybe that changes my mind again. We'll see. But based on what I've seen, based on the patents that we've been able to dig up that they filed, this new filament coloring system could become a bit of a carpet stainer for a lot of people, but I'm very interested to see what it looks like. And of course, we've had confirmation from multiple content creators out there that there are new 3D printers coming down the line from Bambu Labs, so maybe this is a good opportunity to see what they've learned from the X1 series and what they've potentially put into what could be the next. I guess everyone's saying that it's the A1. I've never quite liked the steak sauce, so why ruin a good steak? I am just disappointed. I'm gonna get this thing sent back. I do actually have a second X1 carbon that you guys have never seen on the channel. It was actually sent to us by a fan who was just fed up of dealing with it. I am told that the tool head board has melted. So we're gonna end up doing a live stream on that where we take it apart, we figure out why it's messed up, and we get to order some parts in, get it fixed, and see how Bambu out of warranty support goes. I'll be very curious to see that. Anyways, guys, I'd love to know your thoughts in those comments below. Do you think I made the right decision by sending that machine back? Do you think I'm just too stupid and obviously don't know how to operate 3D printers? Let me know, because Frankly Built recently did a video that I really enjoyed where he read mean comments. We've got a lot of them saved up. Maybe it's time we do something like that as well. Anyways, stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Don't forget to leave a like. Have a good one. Hey, thanks for making it to the end of the video. And a big thank you goes out to all of our channel helpers, whose names are listed right next to me at the $5 tier and higher. It's the Musketeers crew, if you will. Thank you for what you all do in making these videos possible. Right below me will be over 100 episodes of PrintFixFriday, where you can take a look at print failures and how we fixed them. It's great, even if you're experienced, because I get challenged often in these. It is always fun to, you know, keep the gray matter less smooth, if you feel me. And right next to that will be my 6-month review of my Bambu Lab X1 Carbon. It could be better, but it could definitely be a lot worse. I'll see you guys down in those comments and in the next one. Take care.